less than 1/8, 2/1, and 2/4. Vocabulary. Okay, the distance postulate has three parts. First of all, on a line, there is a unique distance between 2 points. Okay, so all that's saying is if I have a line, by the way, lines go on forever. Those arrows indicate goes forever. There's a unique distance between 2 points. So if I put a point here and a point here, there's only one distance between them. That's what the uniqueness property is saying. And that we could put a value to that if we make this a number line. Formula says if 2 points are on a line and they have coordinates x and y, I can still hear myself, which is then you would find the distance between them by subtracting them. Okay, distance is difference, and difference is subtraction. So if you ever want to know the distance between 2 points, you're going to subtract them. Okay? And these bars right here on x minus y, does anybody know what those are? Those bars around x minus y just mean absolute value, which means you can't have a negative distance. So if you do x minus y and you get a negative number, you make it positive, okay? Because you can't have a negative distance. If, for example, let me just show you what I'm talking about, because some of you are looking at me like, what? Let's say I give this, I'm on a number line, and this point is at 5, and this point is at 11. I want to know how far it is from point A to point B. Well, all I'm going to do is subtract one of them from the other, okay? If we do 11 minus 5, we get 6. But let's just say you had decided to go 5 minus and say it was 5 minus 11. Well, that's negative 6. But distances can never be negative, so therefore you'd say, take the negative off, it's 6, okay? Because, and it says if B is, here I have to add something. It should say if B is on line AC, that should go right here. I don't know how that got missed. If B is on AC, then AB plus BC equals AC. Okay, and here's, I'll show you my example right here. Here's a line. Here's A. This is line AC. If B is somewhere on here, somewhere between them, then the distance from A to B plus the distance from B to C has to equal the distance from A to C. That's what that's saying. Forgot about Larissa. If you see no arrows above it, if it's just AB, looking a lot like that right there, there's my lightsaber on it, okay? We call that a segment, okay? And it has 2 endpoints. So your picture would be endpoint A, endpoint B. That's a segment. It stops at those points. What's that? Right, it's not a line. A lot of people will still call it a line, but it's a segment technically. Oh, the next one is totally. The next one is a line. It contains A and B, and so the picture for that one, remember, line contains point A, contains point B, but it keeps going right through A and B. How far does it keep going? Forever. So if I could actually write this, it would just go. It's going forever. Okay? That's still not forever. But it's the best I could do. Alright? It goes through A and B and on to forever. Alright, the next one, where it has one arrow, is called a ray. Alright? It's a ray. Think about a ray gun. Okay? It starts, it's the laser or the ray starts at your gun and goes on forever. Okay, so we call that a ray. Whatever letter it doesn't have an arrow over, that's an endpoint. So in this case, you would have an endpoint, or it's kind of like a starting point really in this case. That's A, and then it passes through some point B, again, on its way to forever. So the picture for a ray would look like that. You have one endpoint and one side that's going through and on to forever. If it has nothing distance between A and B, okay? So if you see that, if it says, for example, if it says find AB with nothing above it, that means find the distance between A and B. Okay, so I guess the picture of that would be A, B. Well, in order to have a value for this, I would have to have a value for them. So once again, let's say A is 1 and B is 4. What's AB then? 3. 4 minus 1 to find the distance. Okay? Remember, distance is difference, and difference is subtraction. So, a polygon is a figure with straight sides that all fence in a certain area, also known as a closed figure with 3 or more sides. Okay?
3 goes 4.
It's got to have 3 or more, okay? Because a triangle is a polygon. A triangle is pretty easy to understand, I think. A convex set is a set in which every segment that connects points of the figure lies entirely inside the figure. I'll explain that. Okay, if you take 2 points in the figure and you connect them, the segment that connects them can never go outside the figure.
Oh.
What?
Kind of hard to
Is this. The midpoint of segment AB is the point M, and this is the big idea which you need to understand so we can do math with it, is that hey, there's nothing above the AM and the MB, so what are those? If there's nothing above them, they are what? Brianna, you know. Like for you when we get to practice. If AM equals 3x plus 2 and MB equals 5x, and I ask you what's the length of AB? I ask you what's the numerical length of AB?
8x plus 2.
If we know that M is the midpoint, then that means that AM, this side, equals MB, this side. So what I need you guys to be able to do is say, hey, 3x plus 2 equals 5x.
It's 2.
I mean, isn't that right? We get all our x's on one side, I'm going to subtract 3x. Okay, so all that we have on the left side now is 2. What's 5x minus 3x? 2x, right? And then to get x all alone, we have to divide what's next to it. So we divide by 2. X equals 2 divided by 2, which is 1. Now remember, we wanted to know the length from A to B. So now if we take this 1 and go plug it in, 3 times 1 is 3 plus 2. From A to M is 5. 5 times 1, x is 1, is 5. So from A to B is how far? 10. 5 plus 5. Okay? So we can solve that AB equals 10. Sorry, it's a little bit sloppy on this iPad screen. Okay?